You ever look up at a giant skyscraper and just think, how? I mean, how does that massive thing, all that steel and glass, not just sink into the ground? We see them reaching for the sky, but the real secret, the thing that keeps them standing, is something we can't see at all. It's the earth underneath. Get that part wrong, and you've got yourself a modern-day Leaning Tower of Pisa. But get it right, and a city can touch the clouds.
So that's the big question, right? It's the #1 challenge for pretty much any major construction project. You can't just cross your fingers and start digging. You have to investigate, you have to understand what you're dealing with. You have to become a kind of detective, a ground detective. Okay, let's get into it.
Here's how we're going to crack this case. First, we'll talk about how you even test ground you can't see. Then we're going to open up the detective's toolbox and look at their go-to gadgets. After that, we'll see how they turn a simple number into mission-critical knowledge. And finally, we'll connect all the dots to see how this work is really the foundation of safety for all of us.
So the folks who solve this mystery, they're called geotechnical engineers. And their job is basically to understand what the earth beneath our feet is really made of. Their secret weapon is a way of investigating that gets information right from the source.
It's called in situ testing, which, yeah, sounds fancy, but all it means is in its original place. And this is a huge deal. You see, if you just dig up some soil and take it to a lab, it gets all disturbed and its properties change. In situ testing is like getting your clues directly from the crime scene without tampering with any of the evidence. And these engineers have a whole kit of tools to do this. They've got tests for how water flows through the ground or how strong soft clay is. But for our investigation, we're going to focus on two of the absolute biggest, most common detective tools used all over the world, the SPT and the CPT. These two tests are the real workhorses of any ground investigation. They might sound a little technical, but the idea behind them is actually brilliantly simple. Let's start with the classic. First up is the Standard Penetration Test, or just SPT for short. This is one of the oldest, simplest, and most widely used methods out there. You can think of it as the brute force approach. It's basically about hitting the ground and seeing what happens. The whole process is really mechanical. First, a special hollow tube called a sampler gets lowered into a drill hole. Then, a 140-pound hammer is dropped onto it over and over from a standard height of 30 inches. All the engineer does is count. They just count how many of those hammer blows it takes to drive that sampler 1 foot deeper into the ground. And after all that, all the drilling and the dropping of this massive hammer and the careful counting, the whole thing boils down to just one single number. It's called the Standard Penetration Resistance, but everybody just calls it the N value. And this one number is our first huge clue. Now, if the SPT is our hammer, then our second tool, the Cone Penetration Test, or CPT, is more like a surgical probe. Instead of hammering something into the ground, a special cone-shaped probe is just pushed down at a slow, steady rate. And as it goes, it gives a continuous stream of data. And this table really lays out the trade-offs perfectly. The SPT hammer gives you data point by point at specific depths, and a huge plus, it actually brings up a physical soil sample you can look at and feel. The CPT probe, on the other hand, gives you this beautiful, continuous picture of all the different soil layers, but it can't push through hard rock, and you don't get any samples back. So, a good detective has to know which tool is right for the job. Okay, so we've got our number, our N value. But a raw number isn't knowledge, right? It's just a piece of data. Now for the most important part of the whole investigation, figuring out what that clue actually means. Let's say our SPT test gives us this number, 31. That's the raw data, straight from the field. It tells us it took 31 hammer blows to drive the sampler that 12 inches. But is that the whole story? Nope, not even close. You see, any experienced detective knows you can't just take a clue at face value. You have to consider the context. Geotechnical engineers have to make corrections. For example, the deeper you test, the more pressure there is from all the soil sitting on top, and that can make the ground seem stronger than it really is. Even things like groundwater can mess with the readings.
So, after the engineers apply these super important correction factors, which, trust me, involve some pretty complicated math, our raw number of 31 gets adjusted, and the real clue, the number that tells the true story of the soil's strength, is 21.
And now for the big reveal. We pull out the engineer's decoder ring. This is a classic, trusted table developed decades ago. We take our corrected N value, 21, we find it on the chart, and boom, right there. It falls in the 10 to 30 range. We've cracked the code. The soil is medium in its compactness. Now we know exactly what we're standing on.
So we went from dropping a hammer into a hole to getting a number, correcting it, and then decoding it. But what does that all mean for the real world? Why does any of this actually matter?
Well, it means everything. Knowing this soil is medium dense isn't just some interesting fact. It is the critical piece of the puzzle. It tells the engineer exactly what kind of foundation they need to design, one that is going to be safe, stable, and won't sink or shift or fail, period.
And I love this quote because it really gets to the heart of it. The tests in the field, they give you the facts, the raw data. But it takes the experience, the skill, the judgment of an engineer to provide the interpretation, to give you the wisdom to make the right call on how to build safety.
And that's really the bottom line. This entire process, the drilling, the testing, the calculations, it's an invisible science. It all happens long before the first steel beam ever shows up on site. But it's the reason our cities can reach for the sky, and it's why you and I can feel safe in the buildings we live and work in every single day.
It really makes you think, doesn't it? Wherever you are right now, there is a structure around you. And you can bet that underneath it, long ago, there was a ground detective who asked the right questions, found the clues, and made absolutely sure it was all built on a solid foundation. So what invisible engineering are you standing on right now?